Hello, everyone. Thank you once again for joining me on this series of AI LLM security. Yes. So basically, there is this, looking at when you find yourself in an environment whereby you are part of, people that make decisions as to how, AI is adopted, as how AI is scaled, and how AI is managed, responsibly within your organization. Then there are a lot of questions that comes to your mind. There are a lot of scenarios that pop up within your systems, and you begin to ask yourself, should in case we have direction that is going this way, what will I say? What will I do? You begin to research, you begin to read about a lot of things and use cases. And one of the things that comes to me, recently is architecting agentic and LLM workloads. And I was working on some stuffs, and it popped to my mind that okay, what if we have a situation like this? Answers, we have questions that needs answers around architecting for agentic and LLM workloads, and that really bothers me, and I begin to work around it. And one of the things I put down here is architecting agentic and LLM workload. It revolves around stuff like Kubernetes, like managed cloud, like the security layer underneath and stuff. Those are the things that popped to my mind initially. And every team building agentic AI right now is really making that decision first, and build it on open source orchestration, you run yourself, or build it on a managed enterprise platform where the cloud provider owns the infrastructure. I want to walk through both parts, properly in this video, including the Kubernetes architecture question that kept, coming back to me, back to me, and put security next to every decision instead of bolting it on afterward. So I want to make this clear that this is a personal experience, and I'm looking at it from the perspective of security. But before security, then I have to look at the architecture itself, because I don't want to build security, after the design or maybe implementation. No, I want security to be part of the architecture, the architecture, the design, and what have you. And before I can do that, I must be able to relate with the requirement and with the available toolings, services, and product that will form the very corner of my infrastructure that eventually I will secure. So that being said, let's go to this. So in my situation and in my case now, case scenario, I figured that in every deployment, there are two things or two decisions that you have to, you find yourself in between, either as an organization or as an individual, security engineer or practitioners. Now, every team is making one decision first, and that decision is should we build it ourselves or yourself, or let the cloud own it? And that is where these two eyes comes to my screen. That is self-managed, agentic or LLM cloud workload, or managed cloud option. Now, when you look at the self-managed, when you are using infrastructure like you're using tools like LangGraph, CrewAI, Microsoft Agent, framework, these are libraries you deploy and operate yourself. You own the environment. The scaling and the security are your responsibilities. But when it goes to the other side, which is managed cloud, then you talk about the tools like managed tools like Bedrock from Amazon, Microsoft Foundry from Microsoft, and Gemini Enterprise from Google, OCI, Agentic Studio from Oracle. The provider owns the infrastructure in this case. You choose the model and you build your agent on top of that. But the infrastructure owned, managed, by the provider. Neither choice is free of security work. That is the very important point I'm making here. Either you choose self-managed or managed cloud, both require security work. The only difference is that it moved where the work lives. So, where the security work lives. So let's move on. So in this video, what I'm going to cover is open source versus managed, cloud. I'm going to cover the Kubernetes cluster question that comes to me most of the time. I'm going to cover the MCP data layer, then the 6 security controls that is expected that you look into while you are making the decision and you're building out your AI workload. Now, from framework choice to 6 controls that apply either ways. First, open source managed cloud. That is the first decision you want to take. You choose the foundation model either ways. The difference is who owns the infrastructure. So either you are doing open source, self-hosted, or you are doing managed cloud. You still have that decision to take, like what is the foundation model, the base model we want to use. And within the open source ecosystem, we are very familiar with the LangGraph, CrewAI, and Agent framework, which is from Microsoft, I think, which is the combination of AutoGen and some other toolings that were merged together. You own the infrastructure, you own the scaling and security posture. But in the case of managed cloud, they own the infrastructure, you choose the model and you build. Across all 4 hyperscaler, you pick the foundation. So either you are using AWS, you're using Google, you're using Oracle, you are using Microsoft, you will still choose your underlying foundation. You can combine, you can do anything, but you have to make that decision. Then the other thing is open source stacks in 2026, where each framework actually stands. So let's look at what has the the numbers when it comes to production and workload. So LangGraph, the largest production footprint, graph-based control maps to audit trace and roll back the enterprise default. So most enterprise use deploy LangGraph, but for prototyping, CrewAI, kind of fast idea to prototype out, maps roles, tasks, and managers, easier curve, less production observability. And then when it comes to merged, the two together, whether you want production, you want prototype, the Microsoft Agent Framework does that. So like I said earlier, it's AutoGen plus Semantic Kernel merged. General availability, it was around April 2026. Both original repos are now in maintenance mode. So if you are using anything like AutoGen now, you're actually using Microsoft Agent Framework. But the point I'm trying to make here is that these are the open source, mostly used open source stacks as of 2026. Now, let's move forward. Managed cloud stack. Like I said earlier, AWS have Bedrock and Agentic Core. In this, we have guardrails for prompt injection. AWS WAF at the front of your gateway, available in Gulf Cloud for elevated compliance workload. And when you come to Azure or Microsoft Foundry, it has been renamed several times, so I'm not going to that. So yeah. So you go to GCP and you see formerly it's now Gemini Enterprise Agent Platform. It's formerly Vertex AI Agent Builder, Agent Space, ADK for Code First, all those kind of things. But one thing that needs to be called out is Agent Engine Runtime and A2, that is agent-to-agent protocol for cross-framework interoperability. So these are the functionality that comes with GCP, managed cloud for AI workload. Then we have Oracle, that is OCI Enterprise Agent, AI Agents. So open AI responses, compatibility, unified API, sovereign AI options for data residency requirements. These are the core capabilities that individual, managed platform kind of bring to the table. So I'm just highlighting that. I'm not marketing for them, so don't worry. So across all 4s, the provider owns infrastructure. You pick the model per use, and you can combine models as well. So what I need to tell you here is that these are the major players in the industry that allows you to build AI workload, agentic and LLM workload on top of their infrastructure, and which they can manage for you. Okay, so let's look at the Kubernetes question. Now, one of the things, the major question that triggered this video is how to architect for both LLM inference and agentic workload. That is what give rise to to everything we have here in this video. Now, the reason why I have to explain some concept before we get to this point is for you to know that when you are taking some decisions, they are based on other requirements and other maybe resources. So let's look at one cluster or 2 clusters. If, for instance, the bottom line in my conversation, or let me say my thinking, is that if we have agentic workload and we have LLM, we are using open source LLM, is it the right thing that the 2 of them should be running in the same cluster, Kubernetes cluster, or they should be running in different clusters? Why should we choose one over the other? So that is what this slide will answer for us. So if they are sharing, so before I move further, let's look at GPU bound inference and CPU bound orchestration scale on different ASICs. Now, if you look at inference systems, they consume GPU a lot. And if you look at the jobs of agentic workload, they are more CPU bound. Now, having that in mind, if our architecture allowed for shared deployment model, like what we have here, okay, here we have orchestration, that is the agentic, agentic layer, plus the inference, which is the LLM layer. If we have them in one cluster here, that is to tell you that both of them, they are running in the same cluster, and the resource contention between workload are scaled on different ASICs, because you need orchestration to scale on CPU ASICs, while you need inference to scale on GPU ASICs. So this is a 2 contradicting, pattern. Then when you separate them, what happens? Let's look at separation here. You have orchestration, which is CPU bound, and you have inference, which is GPU bound. Now, what do you benefit? You have cleanest blast radius boundary, tailored network policy per workload. That shows that when you want to do some security or network policy around this workload, you will be able to say, okay, we are not combining two workloads that are behaving differently. So that shows that we have more granular way of applying some rules and some policies, some protocols around it, and that brings some sanity to the architecture. And that is the point I'm trying to make here, that not a special AI exception, least privilege, network segmentation, and monitored egress apply at full strength, same as any non-cluster. So one thing I want to say here is that I am not talking about this architecture as if there is something new. No, it's just like your normal, non-AI workload. Every security, controls that apply to non-AI workloads should apply here. But it's very important that we begin to look at the specificity and some details that will apply to AI workload that we need to put into consideration as well. So let's go to MCP as data layer. Connecting local model to internal data, retrieval and fine-tuning, not retraining the base model. For a lot of us, we know by now that we don't retrain base model, either open source or commercial source. What we do is that we augment their reasoning. And how do we do that? Now, we do that through connecting that model to an internal data source, an API endpoint, a file server, or whatever, something that contains our internal information that can be used to augment, to reinforce the reasoning of our local model. So, now when you look at local model like Kimi or Llama, what it does is that it connects to an MCP server, and that MCP server connects it to an internal API or data source. So one standardized auditable interface instead of scattering direct data connection across every agent. Now, what does this mean? If your local agent have connection to your data sources via an MCP server that can be controlled, that can be monitored, that can be managed the secure way, that is more better and more secure than having every agent that pop up in your environment to have direct access to your data sources. Yeah. So what you can do is that you can retrain a base model. I've said that. Generally, it's possible for self-hosted or even vendor foundation model. But what you can do is to rag them in. That is your information. That is the way I call it. RAG or fine-tuning via MCP, standardized access control, log retrieval part. So what happens is that MCP allows you to use your internal data sources in a more secured way without necessarily using the data to retrain your base model, but you use to fine-tune the reasoning. So that is that layer I want to explain there. Now let's go to the security layer. Now the sys control that apply to either you self-host, you self-manage, or you are using a managed platform. Now you have to do identity and list privilege. Scope per agent, per two, not one shared credential. Don't use one shared credential for all your agents. Make sure that every agent is credentialed and they are monitored and they are accountable. Then we look at data protection. Make sure encryption at rest and in transit plus anti-exfiltration on output. The output that is generated by your model or by your agent should not be exfiltrated away. Then network isolation, VNet, VP segmentation, inference, orchestration, data sources. For instance, when I was talking about our architectural design, how do we segment the network of our LLM models where it's being hosted, the agentic workload? Maybe we have some, agentic workload that are running in our, in our environment, and we want to make sure they are separate. So all these things should be put into consideration when it comes to network isolation, depending on requirement. Then we talk about AI-specific monitoring, prompt injection detection, guardrails, and output validation. You can see this one is specific to AI workload. So it should be put in as part of the security layer. Then pipeline and data source security. Same rigor extended to training data, RAG corpora, and MCP sources. So the same rigor you use in making sure that you don't train your model with, compromised data or poison data should also be extended to your RAG system and MCP sources. So we look at governance map to controls. The security agent you build are workloads needing the same control. That shows that you have to set controls in place for your security because they are more or less like humans doing the job. Yes. So, okay, let's go to controls in practice. What this look like in production? Now, AWS WAF in front of Bedrock AgentCore gateway, a concrete shipping example. Let's look at this. We have a client that want to access, like your AgentCore. There's a WAF in front of it. Then the agentic runtime at the end of, on the other side of the IP-based access control and rate limiting enforced before a request ever reach the agent. That shows that you must have a mechanism like WAF that will help you to do rate limiting so that people that another agent or maybe bad actors doesn't spam or spoof your endpoint. So a self-managed equivalent, put your own gateway on WAF in front of the orchestration cluster. Do not only the LLM inference endpoint. So there should be a way, if you are self-hosting your agentic infrastructure or LLM infrastructure, you must put a WAF or a gateway, in front of your cluster. Okay. So this is control 3, network isolation, and 4, AI specific monitoring from the previous slide. So that shows that if you bring in, WAF, to enforce rate limiting in your workloads, either managed or self-managed, you are actually implementing the control 3 and control 4 I mentioned earlier. Yeah. Okay. So if you take one idea from this video, what should that idea be? Same discipline, workload that can now act. You see, if you are running a non-AI workload, now that you are running an AI workload, you should have the same security discipline. But the thing is that now you have a workload that can act on its own now, like autonomous agents. So that is why you have to be very more, proactive, very more conscious of security controls and best practices you put in place around your agentic and LLM workloads. Because now you have a workload that can act, that can reason, that can act, that can chain things together and move at a speed that no one ever thought about. Okay, so separate cluster. So for me, for one of the things I would think you will take away from this is separate cluster for LLM inference and agent orchestration when self-hosting. MCP as the standardized data access layer, not scattered agent connection. So don't allow agent to have direct connection to your data sources, but make use of standardized MCP server. Security isn't a separate track from any of these. It is the same infrastructure discipline applied to workload that can reason and take actions now. So that shows that the security you'll be employer applying to your non-AI workload should also apply here. But the only thing is that you should do it from the perspective of the fact that this is more dangerous or more, let me call it more dangerous workload that you need to put under right controls. So full architecture, platform names, and sources in the companion articles. We try and link some of my LinkedIn articles that kind of expatiate on this on the comment section. And if you want to follow me for more, then you can follow me on LinkedIn and on YouTube at Secure Tech with JKA for my YouTube channel. And because I bring this to you as a result of my experience, the questions I ask, the conversation I have in my community, and I want others to learn, I want others to engage me, bring some other fresh perspective to my videos and my conversations so that we can grow and grow together. So thank you once again for joining me on this episode, and see you on the next one.